Good morning, sir. Myself B. Balaji. I am from Triple E department. Now I am going to explain about conditions for maximum efficiency of a GC generator, DC motor, and DC transformer. Firstly, we will see about conditions for maximum efficiency. The condition for maximum efficiency is obtained when differentiating the above equation with respect to I2 and equating it to 0. That gives rise to dn by di2 equals to 0. Then we get I2 square ro square r0 square equals to w0. So here variable copper loss is equals to constant iron loss. And here it is a brief explanation like of copper losses for condition for maximum efficiency. And here the copper loss equals to I1 square R0 R01 square or I square R02 equals to WC copper loss Cu. That gives rise to iron loss equals to hysteresis loss plus eddy current loss. Then we call it as the hysteresis loss we call as WH plus eddy current we call as WE, that equals to iron loss we call as WI. And here we consider primary side as primary input V1 I1 cos phi 1, that efficiency equals to V1 I1 cos phi 1 minus losses by divided by V1 I1 cos phi 1, that equals to V1 I1 cos phi 1 minus I square 1 R01 minus WI, that divided by V1 I1 cos phi 1, that equals to 1 minus I1 R01 divided by V1 cos phi 1 minus WI by V1 I1 cos phi 1. By differentiating both the sides of with respect to I1, we get efficiency on of output. Differentiating efficiency with I1 equals to 0 minus R01 by V1 cos phi 1 minus WI V1 I1 I2 1 cos phi 1, that for efficiency to be maximum d efficiency is differentiated by I1 equals to 0. Hence the above equation becomes R01 by V1 cos phi 1 equals to WI divided by V1 I square 1 cos phi 1, or WI equals to I square 1 R01 or I square 2 R02. So that is equals to copper loss equals to iron loss. The output current corresponding to maximum efficiency is I2, that equals to square root of W1 by R02. So it is the value of the output current which will make the copper loss equals to iron losses. And we can say it as efficiency equals to output by output plus losses equals to output by output plus copper loss plus iron losses, or efficiency equals to input minus losses by input equals to 1 minus losses by input. The point is, it may be noted here that efficiency is based on power output in watts and not in volt amperes. And although losses are proportional to VA, hence at any volt ampere load, the efficiency depends on power factor being maximum at a power factor of unity. And here coming to efficiency of a transformer equals to, as in the case of electrical machines, the efficiency of a transformer at a particular load and power factor is defined as the output divided by the input, the two being measured in same units, that is in watts or kilowatts. Efficiency equals to output by input. But the transformer being highly piece of equipment has very small loss, hence it is impractical to try to measure transformer efficiency by measuring input and output. These quantities are nearly of the same sizes. A better method is to determine the losses and then calculate the efficiency form. And here the condition for maximum efficiency in DC machines, the condition varies from motor to motor, but typically the maximum efficiency is when running at about 80% of maximum speed during a load that is about 20% of maximum stall torque, and exact details should be available from the manufacturer. And this is the graph of resolution per minute and the typical graph of PMDC and permanent moving DC motor performance. And this here on the y-axis we can observe that the efficiency was given, and the x-axis the rating of RPM was given, and here we can observe that torque and amperes and power and efficiency. And the efficiency formula is efficiency equals to output by input into 100, and that equals to input to the motor total power, that equals to voltage into current, and the motor efficiency equals to efficiency of motor equals to 1 minus loss by input. And efficiency of a DC machine equals to electrical motor efficiency is the ratio between power output in the case of mechanical and the power input electrical, and in the case of electrical. And mechanical power output is calculated based on the torque and speed required, that is power required to move the object attached to the motor. And electrical power input is calculated based on voltage and current supplied to the motor. Mechanical power output is always lower than the electrical power input, as energy lost during conversion electrical to mechanical in the various form such as heat and friction and design and of an electrical motor aims to minimize these losses to improve efficiency. For a DC machine, its overall efficiency is given by efficiency equals to total output by total input into 100. And here is the power flow and losses in DC machines. Electrical or copper losses, that equals to I square R losses we can call as, and brush losses, core losses, mechanical losses, stray load losses. And brush losses are considered as PBD equals to VBDIA, and copper losses are considered as armature losses and field losses. Armature losses is PA equals to IS square or RA, and field losses are PF equals to IF square RF. And core losses are the hysteresis losses of an eddy current current losses occurring in the metal of the motor. These losses vary as B square, and for the rotor as the N power 1.5. And this is about a clear explanation about the conditions of maximum efficiency of an DC machines, DC generator, DC motor, and this is explanation, sir. Thank you very much, sir.